This is a set of examples for solving simultaneous equations. When I look at this set of equations, I notice that it is perfectly set up to do the addition or elimination method. The reason why I notice this is I have a positive 3y and a negative 3y, and if I add those two equations together, my y values will cancel out. 2x plus 4x is 6x, 3y plus negative 3y is 0, and 11 plus negative 5 is 6. So when I add those two equations, I'm left with 6x equals 6. Two things side by side is multiplication. So to get the x totally alone, I need to divide both sides by 6, and therefore the value of x is 1. Now I need to choose. Which one of those equations should I plug it back into and solve for y? It really doesn't matter. Personally, I like to avoid negatives, so I'm going to use the first equation. 2x plus 3y equals 11. Again, when things are side by side, that means multiplication. So I need to do the problem 2 times 1 plus 3y equals 11. 2 multiplied by 1 is 2, so 2 plus 3y equals 11. And now it's just a simple two-step equation. How do I get rid of a positive 2? That's right, I subtract it from both sides. Therefore, 3y is equal to 9. How do I get the y alone? Divide by 3, and therefore y equals 3. Now remember, we're trying to solve for a coordinate pair, xy, so my answer is the coordinate pair, 1, 3. This is another example for solving simultaneous equations. I need to decide, do I want to do the addition method or the substitution method? What I notice here is this x term does not have a coefficient. I can force that term to be anything I want. So this would actually be very easily done as the addition method, which is also called the elimination method. Because this is a positive 3 on the x term, I want to turn this one into a negative 3 on the x term, which means we're going to multiply this entire equation by negative 3. Negative 3 times x is negative 3x. Negative 3 multiplied by 3y is negative 9y. And negative 3 times 8 is negative 24. Now bring down the second equation as it was. 3x minus 4y equals negative 2. And now, when I add the new equation in red with the original second equation, which is in black, we get negative 13y equal to negative 26. Get y alone by dividing on both sides by negative 13. And therefore the value of y is 2. Now I need to choose. Which of my two original equations shall I plug that into? Personally, I think the top one looks easiest. So let's plug in a 2 right there. It becomes x plus 3 times 2 equals 8. 3 times 2 is 6, so x plus 6 equals 8. Get rid of a positive 6 by subtracting. Therefore, x is 2. And as a coordinate pair, the solution is 2, 2. Done.